Okay, now let us substitute the values in this. Just copy this equation, or sigma 1 square, sigma 1 is 48.46. So just make this square. So sigma 1 square is 48.46 square. Sigma 2 is minus 25.82 square. In minus sigma 1, sigma 2, right? So let me just put them in bracket as well. It is 48.46 into minus 25.8, right? So this is equal to sigma permissible. So from this I can calculate the permissible stress, or sigma permissible is equal to, now let us just calculate this. 48.46 square plus 25.82 square. Now here this is minus into minus, so it will become plus. So plus 48.46 into 25.8. So this is RHS, sorry, LHS, and that is equal to sigma permissible square. Take a root of this, so it will become 65.32 megapascal. So this is the permissible stress at point A. Now factor of safety, we have factor of safety is equal to yield strength SYT by permissible tensile stress. So SYT is 280 by permissible is 65 point. Permissible, or you can call it as induced also, right? So this is equal to 280 by 65.32. So it is 4.28 or 29. 4.29 is the factor of safety. This is based on stress element A. Now the same thing I have to do for stress element B. So this will be 2 FOS based on stress element B. Now let us see this diagram. Element B is at this point. So when the force F is applied, there is tensile stress at point B, right? Which was 0 at point A. Now in this stress element, this will remain same, shear stress will remain same. I will have to add a component which is the bending stress, like this. Let me just copy this. Right? So this is bending stress. Right? Now considering this stress element, you have to calculate the factor of safety. So let me just take it back here. Okay. the stress element, the stress on element B is shown in figure below. This is the figure. I'll make it smaller. Okay. Now let us find the principal stress. So I'm just going to copy this equation and I'll reuse here. Now there is a slight change in this. What is the change? See, in case of point A, I had only one normal stress which was tensile. Now I have tensile stress in two directions. One is because of bending and the other one is because of tensile force. So you will have sigma x, sigma y. Two stresses will be there. So to distinguish between them, I will change this as sigma t, right, plus sigma b. Sigma b is bending stress, sigma t is tensile stress, right? So the same thing will go inside, but it is not plus, it is minus, right? So sigma t plus sigma b by 2 plus root of sigma t minus sigma b by 2 whole square plus tau square. So this is the change we have to do in this part. Now let us calculate this. So sigma b is 166 if I'm not wrong. Yes, sigma b is 166. So I have to put that as 166. So this is 22.64 plus 166 and this is 22.64 minus 166. Now this calculation becomes quite complex. So what I will do is I will find this term and the term inside the bracket, right? So I'll find them separately and then we can find sigma 1 and sigma 2. So I'll just call this as sigma p and I'll change this plus to plus or minus. Okay? Or sigma p is equal to this term separately 22.64 plus 166 by 2 is 94.32. 94.32 plus or minus. Now this term I have to do. So here it is minus, so 22.64 minus 166 is this by 2 is this and I have to square it. It became positive plus 35.37 square. The total is this and I have to take root of this. So when I take root it becomes 79.93. 79.93 MPa. Now major principal stress or max principal stress will be sigma 1 is equal to this plus this and minimum. Principal stress is sigma 2, and that will be this minus this. So by looking at this, I can understand both will be tensile in nature. 94.32 plus 79.93 is 174.25. That is sigma 1, and sigma 2, 94.32 minus 79.93, that is 14.39 megapascal. Right? So now I have sigma 1, sigma 2. I can calculate the factor of safety using the distortion energy theory. Now, according to maximum distortion energy theory, this is my equation. Right? Now you have to just put the values of sigma 1, sigma 2 in this expression. So I will just copy the entire thing, because I have to just repeat the same thing for point 2. So this sigma 1 is 174.25, and sigma 2 here is 14.39. Again, this will be 24.25, and this is 14.39. So sigma permissible or induced tensile stress 174.25 square plus 14.39 square minus 174.25 into 14.39 is this much. Root of this is 167.52 megapascal. So for factor of safety is SYT by sigma permissible 280 by 167.52. So definitely it is going to be less than that. 280 by 167.52 is 1.67. 1.67 is the factor of safety at this point.